Hello everyone and welcome to our meteorology unit. In this video, today we'll be discussing the basics of meteorology and how to track/predict storms. There will be 2 assignments and 1 with video. At the end of this class, you'll be required to take the final test, which under passing, you'll be given your role and you can get started working. Alright, so let's begin. Storm fronts. There are 4 types of storm fronts, including cold fronts, warm fronts, stationary fronts, and occluded fronts. Cold fronts. A cold front is a boundary of cold air pushing through a certain area, usually coming from the north. Warm fronts. Just like cold fronts, warm fronts bring hot air over an area, usually coming from the south. Stationary fronts. A stationary front is a pair of air masses, neither of which is strong enough to replace the other, on a weather map. This is shown in an interplaying series of blue spikes pointing one direction, and red domes pointing the other. They tend to remain essentially in the same area of extended periods of times, and waves sometimes propagate along the frontal boundaries. Occluded front. An occluded front is when a cold front overtakes a warm front. Now we're into thunderstorms. How are thunderstorms formed? Thunderstorms are made by evaporating water into the atmosphere. Once the water has cooled off in the atmosphere, it becomes liquid as rain. This is the point where gravity takes over and the raindrops begin to fall. Hail. Hail is formed when a storm has a strong updraft and pulls cool, moist air up in the storm. When the droplets reach the atmosphere freezing zone, they begin to crystallize into ice pellets. If the storm is strong enough, these pellets will gain droplets of liquid around them, then freezing, making the hail bigger in size, creating layers. Eventually, the hailstones will get too heavy for the updraft to hold it up, and the stone will fall to the ground with strong force. Supercells. We all know supercells. A supercell is a severe thunderstorm involving a mesocyclone, a strong rotating updraft. Mesocyclones usually involve damaging hail, strong winds, and sometimes tornadoes. However, not all supercells form tornadoes. Hook echoes. A hook echo is a type of supercell. Hook echoes often form tornadoes, but not always. In this image to the right, you will see an example of a hook echo. In this example, B is the most probable location for a tornado to form. Bow echoes. A bow echo is a bow-shaped thunderstorm bringing heavy rain, extremely high winds 50 mph plus, and hail. Some bow echoes have the chance to form tornadoes, but not common with these systems. Squall lines. A squall line is similar to a bow echo, but cannot always be bow-shaped. Squall lines can produce flash flooding, heavy rainfall, and strong winds. How to spot tornado on a radar. There are multiple tools you can use to find tornadoes on radar. SRV, storm relative velocity for wind shear and rotation. SW, spectrum width, showing highlighted areas and possible rotation. And last of all, CC, correlation coefficient. This can be used to spot irregular change in the precipitation particles, spotting debris, but is not always the case, the last resort. And last but not least, we have symbols. TVS, tornadic vortex structure, which indicates tornadic rotation. So the second icon is a hail icon, showing the magnitude with the number and showing the severity with the color. The third one is a funnel cloud icon. So if some spotter finds a funnel cloud or reports it to the National Weather Service, this icon will pop up on your radar. And last but not least, the tornado confirmed icon. If you see this, that means that some spotter or storm chaser, anyone who's reported this storm to the National Weather Service, means that there's a tornado on the ground or was on the ground. Alright guys, well I hope you all enjoyed that. It was a quick little demonstration. I hope you guys learned a lot from this. Alright guys, I'll see you in the next one.